Nuclear War Survival Skills, Chapter 10, Fallout Radiation Meters, page 103. A more expensive direct reading 600 rads dosimeter is model 019-006 of Atomic Products Corporation, P.O. Box 1157, Center Moriches, New York 11934. It sells for $120. Dosimeter charger 020-001, used to zero all direct reading dosimeters, costs $98. Probably costs a lot more now because this book was written back in the day. To keep them dependable, all commercially available dosimeters and dose rate meters should be kept supplied with fresh batteries for charging or operating. Number 2, checked with a strong enough radiation source at no longer than 3-year intervals to see if they still are measuring radiation accurately. And number 3, repaired if necessary. To learn whether a dose rate meter still is functioning, use a radioactive check source such as Dosimeter Corporation's check source model 3001 that contains 5 microcuries cesium-137 and sells for $35. This type of check test will provide only that your instrument measures dose rates slightly above normal background radiation. It will not prove that your instrument could accurately measure the much higher dose rates that will be of vital concern in a nuclear war. Some instrument companies will properly calibrate a radiation measuring instrument that is sent to them. For example, Dosimeter Corporation charges $50 to calibrate a dose rate meter or dosimeter and makes needed repairs at an additional cost. The reader is advised to buy at least a good commercial dose rate meter with which to quickly measure high levels of fallout radiation if he can afford one. A family that has a reliable dose rate meter and that remains in a shelter almost all of the time during which fallout dose rates outdoors are dangerously high can calculate with sufficient accuracy the accumulated doses received by its members. To do this, a continuous record must be kept of dose rates and the times at which those measurements are made. Having a reliable dosimeter eliminates the need for keeping such detailed records and making these calculations. But if only one instrument can be afforded, it should be a dose rate meter. A good commercial instrument, if properly maintained and periodically calibrated with a radiation source to check its accuracy, probably will be serviceable for years. A prudent owner of even an excellent dose rate meter would do well to make and learn to use a KFM, the dependable home makeable fallout meter, briefly described later in this chapter, with complete instructions for making and using it given in Appendix C. Then, during a period of heavy war fallout, you can check the readings of your complex instrument by comparing them with those of your KFM. And if the complex instrument is giving inaccurate readings, your KFM will meet your basic need. A home makeable dose rate meter, the KFM. What is a KFM? The only do-it-yourself fallout meter that is accurate and dependable was invented in 1977. It is called the KFM, which means Kearney Fallout Meter. Kearny Fallout Meter. Kearney Fallout Meter. One is pictured in figure 10.1. Figure 10.1. A homemade Kearney, whatever the hell that was, something meter. Kearney something meter. Fallout meter. Kearney fallout meter. An accurate dose rate meter for measuring dose rates from 30 what the hell was it, rays or radons an hour, 0.03 radon, that was what it was, micro radons an hour, 0.03 radons an hour, up to 43 radons an hour. This simple instrument has undergone rigorous scientific testing in several laboratories, including Oak Ridge National Laboratory. Its accuracy and dependability were confirmed. Many hundreds of Kearney fallout meters have been made by untrained people, ranging from members of junior high school science classes to grandmothers making them for their children and grandchildren. These successful makers have been guided only by thoroughly field-tested instructions and patterns, not quite as good as the improved ones given in Appendix C of this updated book. Only common materials found in millions of homes are needed to build a Kearney fallout meter. If all of the materials, including those for a dry bucket, have to be purchased, their total cost in 1986 is less than $17. The Kearney fallout meter serves as an accurate dose rate meter when used in conjunction with a watch and the Kearney fallout meter's attached table relating changes in readings in listed time intervals to dose rates. No radiation source is, end of page. Page 104. Needed either to initially calibrate a Kearney fallout meter or subsequently to check its accuracy. Calibrations for accuracy were completed at Oak Ridge National Laboratory and are the basis of the Kearney fallout meter's attached table. A Kearney fallout meter is more accurate than most civil defense instruments, and its accuracy is permanently, that's highlighted, established by the laws of physics applicable to the specified dimensions and other characteristics of its parts, and to their positioning relative to each other, provided that it is made and maintained according to the instructions. All of that's highlighted. Unlike all factory-made radiation measuring civil defense instruments that are reliable and available today, a Kearney fallout meter is charged electrostatically. No batteries is needed. Additional advantages of Kearney fallout meters. A Kearney fallout meter combines the provenly practical radiation measuring functions of an electroscope and of an ionization chamber having a specified volume. Electroscopes were the basic radiation measuring instruments used by scientists, including Nobel laureate Lord Rutherford, who pioneered studies of atomic nuclei and radiations. The author is indebted to another Nobel laureate physicist, Dr. Luis W. Alvarez, for the idea of making a homemade electroscope with two thread suspended aluminum foil leaves to measure fallout radiation. Many excellent and unavoidably expensive dose rate meters, including civil defense instruments, are ionization chamber devices. A Kearney fallout meter used in conjunction with a watch does not have to be charged to any specified initial reading or discharged by exposure to radiation to any specified final reading. To accurately measure the dose rate during a time interval specified on its attached table, Figure 10.2 illustrates this operational advantage of Kearney fallout meters. Here it shows observed separation of lower edges of leaves, and it's in millimeters. On the bottom you have 0 all the way up to 20. Something is marked right there. Adjusted calibration curves of Kearney fallout meter. 20G and KFM 20 both have 8-ply leaves of standard aluminum foil. The calibration readings have all been adjusted graphically to simulate all initial leaf separations being equal. The little circle equals KFM 20I at 2.5, I'm assuming this is radons an hour, 60-second exposures. The little triangle equals KFM 20I at 2.0 radons an hour, 60 seconds exposures. The X equals KFM 20G at 2.5 radons an hour, 60 seconds exposures. The little square equals KFM 20G at 2.0 radons an hour, 60-second exposures. And lastly, the little star equals KFM 20Gs at 10 radons an hour, 30-second exposures. And here's the grid. On the bottom of the grid, it says gamma dose, low cap M next to capital R. So I'm thinking that's microradons. On this end, it's 0, then 40, all the way up to 200. It starts with the little star, and it goes down. It ends with a little circle, which was the KFM right there. Figure 10.2, normalized calibration points for 2 Kearney fallout meters, showing the straight line relationship between milli-row antigen radiation doses and resultant readings. The complete instructions for making and using a Kearney fallout meter, see Appendix C, explains how an operator with a watch can use this instrument to accurately measure dose rates. End of page.